Investments, annuities, and bonds. Part 1. Series of investments. Many people save regularly for the future, especially to provide themselves with a pension on retirement. The value of a series of regular investments can be found by using the formula for a geometric series. Eric starts a saving policy with his bank. He starts by saving €100 now. Each year, the value of the saving he makes grows by 4% to take account of inflation. He makes 20 annual savings and his policy matures at the end of the 20th year. Throughout this period, his fund is guaranteed to gain an interest at an AER of 3%. So inflation. In economics, inflation is a sustained increase in the general price level of goods and services in an economy over a period of time. Part 1. Obtain an expression for F1, the value of his first payment when the policy matures. So we're going to use the compound interest formula on page 30 of the formula book, which is P equals A times 1 plus I to the power T. The first saving of €100 grows for 20 years at 3% per annum, per year. So we're going to swap the A for 100, the I for 0.03, and the T for 20. So F1 is equal to 100 times 1.03 to the power of 20. The 4% for inflation is not applied here because this is his first payment, which is paid now. But the inflation is applied to the savings he makes, which happens at the end of the first year or start of the second year. Part 2. Obtain an expression for F2, the value of the second payment when the policy matures. So again, we use the compound interest formula. His second saving is €100 times 1.04. So where did we get this from? Well, the €100 is the amount he saves, and the 1.04 comes from the 4% inflation. So it's the €100 times the 4% inflation. So that's where this comes from. So that's going to be our A, 100 times 1.04. It's the €100 he's saving timesing the 4% inflation. This grows for 19 years, so T is going to be 19, at 3% per annum, per year. So the I is going to be 0.03. So 1 plus 0.03 is 1.03. So we end up with F2 equals 100 times 1.04 times 1.03 to the power of 19. The 4% for inflation is applied once here because this is his second payment, which is paid at the start of the second year. So although it said in the question he makes 20 annual savings, the T is not 20 because remember this is his second year, his second saving. So in the second year there's 19 years left. Part 3. Obtain an expression for F20, the value of the last payment when the policy matures. Again, we use the compound interest formula. The last saving is €100 times 1.04 to the power 19. So the A is 100 times 1.04 to the power 19. So where did this come from? Well, again, the 100 came from the amount he saves. And the 0.04 comes from the 4% inflation. And it's to the power of 19 because at this point there's been 19 years of inflation. The 4% for inflation is applied 19 times because this is his last payment, which is paid at the start of his 20th year. But inflation is applied to the savings he makes, which happens at the end of the 19th year, or you could say the start of the 20th year. So at this point, inflation has only been applied 19 times, because remember, inflation was not applied to the first payment, because the first payment was made at the start of the first year. So this is the start of the 20th year. Part 4. Determine the value of Eric's saving policy when it matures, i.e. when he gets the value of the policy. So just to recap, F1 was 100 times 1.03 to the power 20. F2 was 100 times 1.04 to the power 1 times 1.03 to the power of 19. And by the same token, or by the same idea, F3 is 100 times 1.04 to the power 2 times 1.03 to the power of 18. And F4 is 100 times 1.04 to the power 3 times 1.03 to the power of 17, and so on. Notice that as the years increase, so F1, F2, F3, F4, F5, F6, F7, up as far as F20, these are the years, the payments. The power stuck on to the inflation, which is the 0,4, starts to go 1, 2, 3, 4, 5, 6, up as far as 19. And the power stuck on to the actual interest goes down. So our interest was 0.03, and initially the power was 20, then 19, 18, 17, 16, 15, 14, down as far as 1. The value of Eric's savings policy at the end, i.e. on maturity, is S20, which is F1 plus F2 plus F3 plus ... up as far as F20. So basically adding all these together, which is 100 times 1.03 to the power 20, which is F1, plus 100 times 1.04 times 1.03 to the power 19, which was F2, plus ... up as far as 100 times 1.04 to the power 19 times 1.03, which was F20. So basically adding all these together. So the value of Eric's saving policy at the end, i.e. on maturity, is S20, which equals F1 plus F2 plus F3 plus up as far as F20. So here we have F1, here we have F2, up as far as F20. So we're going to use our series formula, which is Sn equals A times 1 minus r to the power of n divided by 1 minus r. This is on page 22 of our formula book. This is a geometric series with A equaling 100 times 1.03 to the power 20. So that was term 1, which is A. And that actually equals 180.6111 to 4 decimal places. So that's going to be our A. And when we substitute into our formula, that's where we put it there. The or, the common ratio, is term 2 divided by term 1. This is term 2, and this is term 1. So term 2 divided by term 1 gives us 1.0097087. So that's going to be our ratio, that's going to be the or. So we have it on the numerator and in the denominator. And n is going to be 20 because there's 20 payments. So the n is 20. So we end up with S20 equals 180.6111 times 1 minus 1.0097087 to the power 20 divided by 1 minus 1.0097087, which gives us €3,965.62. Thus the value of the policy when it matures is €3,965.62.